Hello everyone. Today we are going to one dimensional motion, displacement, velocity and acceleration. I am Assistant Professor Swapnil Sampatrao Shinge, Head Department of Physics, KAANMS ACS College, Satana. So today we have to start with the kinematic. As we all know, the kinematics is nothing but the geometrical description of motion, and kinematics describe quantitatively how a body moves through space. We will begin by treating the body as rigid and non-rotating, so we can fully describe the motion by following its center. Another word, kinematics, related with this, dynamics. So dynamics is nothing but the cause of motion, and here dynamics accounts for the observed motion in terms of forces, etc. We will get to that later. Okay. So measuring motion, a frame of reference. Here is the diagram of three-dimensional which has x axis, y axis, z axis. The frame can be envisioned as 3-meter sticks at right angles to each other, like the beginning of the frame of a structure. To measure motion, we must first measure position. So we measure position relative to some fixed point O called the origin. We give the ball's location as x, y, z. We reach it from O by moving x meters along the x-axis, followed by y parallel to the y-axis, and finally z parallel to the z-axis. One dimensional motion, distance traveled and displacement. The frame of reference in one dimension is just a line. Think of a straight rod. This is the line which has points -1, 0, 1 and x-axis. This time we have made explicit that x-axis also extends in negative direction, so we can label all possible position. Driving a car, the distance traveled is what the odometers read. The displacement is the difference x2 minus x1 from where you started to where you finished. That means displacement is nothing but smallest distance between initial and final position points. They are there are they are only the same if you only go in one direction. Displacement is a vector. A displacement along a straight line has magnitude and direction. That means plus or minus. That means it's a vector because it has a direction. If the displacement delta x is equal to x2 minus x1, magnitude is written mod of delta x is equal to mod of x2 minus x1, because the direction has positive or negative signs, but the magnitude does not have any sign. So therefore we have taken mod. Direction is indicated by attaching an arrowhead to the displacement. For example, here we are giving arrows like the student travel from Nashik to Satana or come back, that is means traveling from Satana to Nashik. Here another topic is average speed and average velocity. As we all know, average speed is equal to distance car driven upon time taken. That means total distance covered upon total time taken. Average velocity is nothing but the total displacement upon total time taken to displace that distance. So average velocity is a vector. It can be negative. Formula for average velocity: v bar is equal to x2 minus x1 upon t2 minus t1. That means x1 is the initial displacement, x2 is a final destination point, and to time take that portions. So t1 is a time at x1 and t2 is nothing but the time required to reach x2. So here v bar is equal to delta x upon delta t. For example, a round trip of Richmond, average speed 60 miles per hour is nearly equal to 27 meter per second. So average velocity is equal to 0 because there is no change in speed. So that's why average velocity is 0. Instantaneous velocity, that's the velocity at one moment of time. Car speedometer gives instantaneous speed. To find this, need to find car's displacement in a very short time interval to minimize speed variation. Mathematically, we write v is equal to limit delta t tends to 0 delta x upon delta t, which is equal to dx upon dt. The limit just means taking a succession of shorter and shorter time interval at the moment in time. Here is average speed example. If you drive 60 miles at 60 miles per hour, then 60 miles at 30 miles per hour, what was your average speed? Okay, so if we traveling 60 miles per 60 mph, so it takes our single speed, that means 60 miles per hour. But to cover 60 miles at 30 miles per hour speed, then it will take doubles. So we have to 60 plus 60, 30 plus 30 divided by 3. So we get this value is nothing but 40 miles per hour. Okay, average trip speed, you drive 60 miles at 60 miles per hour, 60 miles at 30 miles per hour, what was your average speed? Already we have discussed, but here we have mentioned the total distance is 120 miles and time taken for 3 hours. So 120 upon 3, so we get 40 miles per hour. Our units for one dimensional motion, so displacement has a unit meters. It can be positive or negative because displacement is a vector quantity. Velocity, rate of change of displacement, so units are meters per second and it can be written as m per s or meter second inverse, equal to rate of change in velocity. Acceleration is nothing but a rate of change of velocity. Here acceleration word is not visible, so we can understand it that acceleration is nothing but the rate of change of velocity and its unit is meter per second and it can be written as meter per second squares. Okay, so for preparing this video, these are the references used to prepare this video. Thank you friends.